Now we're going to look into Pure Maths 1, October, November 2024, Variant 2, question number 7 to question number 10. So let's begin. Question number 7. By expressing negative 2x squared plus 8x plus 11 in the form of this, so it's a vertex form. So in order to convert into this form, we will use the completing the square method. So you also can use calculator to find out the a, b, and c if you want. But I just show you the full working of completing the square method. So here, first I will factorize the negative 2. So negative 2. So x square minus 4x. So I usually will only factorize a and b. So c I will just rewrite as it is. And then negative 2 x square minus 4x plus negative 4 over 2 square minus negative 4 over 2 square plus 11. So negative 2 will be x minus 2 square minus 4 plus 11. So negative 2 x minus 2 square minus plus 8 plus 11. Therefore negative 2 x minus 2 square plus 19. Or even you can use some formulas there, you can use that also in order to convert this. Okay. And then they ask for the vertex of the graph. Okay, the question asks you the vertex. The vertex means here the turning point. So the turning point of the graph will be 219. Okay, if you still remember from this, so negative a x minus b square plus c. So the vertex will be bc. That's it. Okay, this will be the vertex. For b, the diagram shows a part of the curve with the equation y equal to negative 2x square plus 8x plus 11 with the line equation 8 plus 8x plus 9. Find the area of shaded region. So if you want to find the area of shaded region, I'm going to integrate from here a to here b. I need to integrate. So it's going to be integral from a to b. So the top curve, so I make it the curve y1 minus y2 dx. So this is the formula that I'm going to use. So in order to do that, I need the coordinate a and b. Okay, I need the coordinate a and b. Okay, so a and b. So for that, I solve this equation. So it's going to be, I equate negative 2x square plus 8x plus 11 is equal to 8x plus 9. So it's going to be negative 2x square equal to negative 2. Therefore, x square equal to 1. So your x equal to plus minus 1. So it's going to be a equal to negative 1, b equal to 1. Which means I'm going to integrate negative 1 to 1, negative 2x square plus 8x plus 11 minus 8x plus 9 dx. So I just use this formula. Okay, the top curve y1, and the bottom curve is y2. Or even you can directly integrate the curve and then minus with the area of trapezium also can. Okay, but I will prefer this method. So it's going to be integral of negative 1 to 1, negative 2x square 0 plus 2 dx. So it will be 2x cube over 3 plus 2x, negative 1 to 1. So it will be negative 2, negative 1, over 3 plus 2, 1 minus negative 2, negative 1 cube over 3 plus 2 bracket negative 1. So you press this in your calculator. you'll get 4 over 3 minus negative 4 over 3, which is going to be 8 over 3. Okay. Question number 8. The equation of a circle x square y square px 2y plus q equal to 0 where p, q are constant. Express this in terms of x minus a, y minus b, and r square is given a to be, where a is to be given in terms of p and r square is given in terms of p and q. So this is general form. So from general form, we want to form into the vertex form. We will use the completing the square method. So first, I rearrange of this. So it's going to be x square plus px plus y square plus 2y plus q equivalent to 0. So it's going to be x square plus px, or even you can, sorry, you can use the formula. So if you still remember the formula, it's going to be 2x square plus y square plus 2fx plus 2gy plus c equivalent to 0. And from here is going to be negative f and negative g is the center, where this one we can convert as x plus f square plus y plus g square equal to r square, where r square is equivalent to f square plus g square minus c. Okay, so from here we can know that my p, if I want to convert this into this form, is going to be x square plus y square plus 2p over 2 x plus 2 1 y plus q equivalent to 0. Okay, therefore it's going to be, so negative f is going to be x plus p over 2 square plus y minus 1 square is equivalent to, so my r square will be negative p over 2 square plus it should be plus here, sorry, plus negative 1 square minus q. So it's going to be, since here the question asks for your minus, so it's going to be x minus negative p over 2 square plus y minus negative 1 square, because this negative negative is positive, right? So my a here is negative p over 2 and q is 1 negative 1 is equivalent to, I just leave it in this form, so it's going to be p square over 4 plus 1 minus q. Okay, so if you can relate the general form, if you can relate the general form to the vertex form, okay, it's fine. Let's say you are not able to relate the general form into the vertex form, you can also use completing the square method to perform this. Okay, but I think completing the square will be a longer step, but it will be easier for you if you compare straight away from the general form into the vertex form of the circle, equation of the circle. Okay, for B, the line with the equation x plus 2y equal to 10 is tangent to the circle at point A. So we just assume it's something like this. Okay, so this is point A, and this is the line which is tangent. Okay, find the equation for normal to the circle at point A. So since we have this equation, so it's going to be y equal to negative 1 over 2x plus 10. So from there, we know that gradient of a tangent is equal to 1 over negative 2. So gradient of a tangent multiply gradient of a normal equal to negative 1. Therefore, gradient of normal is equal to 2. Okay, so you can directly y equal to 2x plus c. So when x equal to 4, y equal to 3. So 3 equal to 2, 4 plus c. Therefore, c will be negative 5. Therefore, y equal to 2x minus 5 is the equation of a normal. So equation of normal is normally go through the center. Okay, so this is the center. Okay, this is the normal. Okay, find the values of p and q. Okay, so what we know just now, the gradient of a normal is 2 and this is the gradient. So by the basic thing where here the coordinate will be negative p over 2 and negative 1. Okay, so you can take this, substitute inside and you can get the p. So when x equal to p over 2, y equal to negative 1. So negative 1 equal to 2 bracket negative p over 2 minus 5. Therefore, 4. So p equal to negative 4. Whereas, in order to find the q, I need to know the distance so that I can have the r. So r, you can use this formula. So that r, you can use this. So I need to know my distance, my r. So the coordinate is 4, 3, and negative 4, negative 1. Am I correct? Let me check. Negative, oh sorry, now 4, negative 4 over 2 is 2. So 2. Okay. So my r square will be 4 minus 2 square plus 3 plus 1 square. So my r square will be 20. So from the equation just now, okay, so from here, this is my r square. So p square, okay. So p square over 4 plus 1 minus q equivalent to 20, where my p is negative 4. So negative 4 square over 4 plus 1 minus q equal to 20. Therefore, you can find your q is equivalent to negative 50. So your final answer, p equal to negative 4, q equal to negative 15. That's it. Okay. Question number 9. The equation of a curve is y equal to 1 over k square x square minus 2kx plus 2. And the equation of a line is y equal to kx plus p, where k and p are constants, where k is between 0 to 1. It is given one of the point intersection of the curve and the line as a coordinate 5 over 2, 1 over 2. Find the k and p and find the coordinate of other point of intersection. Okay. So since it says a point of intersection, we can directly substitute your x and y inside and then we can solve this. Before that, I just equate the equation first. So it's going to be 1 over 2 k square x square minus 2 kx plus 2 equal to kx plus p. So when x equal to 5 over 2, sub in. So 1 over 2, 5 over 2 square, k square minus 2, 5 over 2 k plus 2 is equivalent to k 5 over 2 plus p. Okay. I have a P as well. Okay, I'm sorry. So since it satisfy, sorry, so I think I can directly substitute in. I'm sorry. So I can substitute in directly here. So when x equal to 5 over 2, y equal to 1 over 2 second. Substitute here, so it's going to be 1 over 2 k square x square, where my x equivalent to 5 over 2. So 1 over 2 k square 5 over 2 square minus 2 k 5 over 2 plus 2 equal to 1 over 2. Okay, so when you simplify this, you will get 25 over 8 k square minus 5k plus 3 over 2 equal to 0. So multiply everything with 8, so we'll get 25k square minus 40k plus 12 equal to 0. So it's going to be 5k minus 6, 5k minus 2 equal to 0. Therefore, k equal to 6 over 5, k equal to 2 over 5. Since k is between 0 to 1, therefore k equal to 2 over 5. So y equal to kx plus p. Kx plus p. So x y equal to 1 over 2, k is 2 over 5, x is 5 over 2 plus p. So these two I take from here, 5 over 2 and 1 over 2. Okay. Therefore, my p will be negative 1 over 2. Okay. And then find the other point of intersection. So now I need to equate these two equations. So it's going to be 1 over 2 k square. So my k is 2 over 5. 2 over 5 square x square plus 2kx. So 2kx plus 2 equal to kx plus p. Okay. So you rearrange, you get 2 over 25 x square minus 4 over 5 x plus 2 equal to 2 over 5x minus 1 over 2. Rearrange 2 over 25 x square minus 6 over 5x plus 5 over 2 equal to 0. So you multiply everything with 2 over 8 over 25, so you get 4x square minus 60x plus 125 equal to 0. Therefore, 2x minus 25, 2x minus 5 equal to 0. So x equal to 25 over 2 and x equal to 5 over 2. So this is already given. So another coordinate will be this. So you can use the equation y equal to kx plus p. So y equal to k is just now 2 over 5 and x will be 25 over 2. 25 over 2 minus p. So your y will be 9 over 2. Therefore, another coordinate of intersection will be 25 over 2, 9 over 2. This is another coordinate of intersection. Okay. Now B, it is given that instead of the line and curve does not intersect. So they are not intersecting. Find the set of possible values of P. So we equate and then we do B square minus 4AC and less than 0. Okay, we equate these two equations. So 1 over 2 k square x square minus 2 kx plus 2 equal to kx plus p. Okay, rearrange. So 1 over 2 k square x square minus 3 kx plus 2 minus p equal to 0. So we use discriminant b square minus 4ac less than 0. So my b here is negative 3k square minus 4ac less than 0. Okay, since it's going to be 9k square minus 2k square 2 minus p less than 0. Since k is a positive, so I can bring this on the other side. So it's going to be 2 2k square 2 minus p will be more than 9k k k square. So 2 minus p more than 9 over 2. So negative p will be more than 5 over 2. So p is less than negative 5 over 2. Okay, because I just divide with this. Okay, and because k square is always positive, so it will be divisible. And the last question, a function f with the domain x more than 0 at this, find the equation of a normal at 1 0. So equation of normal is will be, so first we substitute, we find f prime 1, so it will be 8 2 1 minus 3 1 over 3 minus 10 1 2 over 3. So your f prime 1 will be negative 18. So this is the gradient of tangent. Okay, so gradient of normal will be gradient of normal multiplied with negative 18 equal to negative 1. So m equal to 1 over 18. Okay, therefore y equal to mx plus c. When x equal to 1, y equal to 0. Therefore c equivalent to 1 over 18. Okay, sorry, negative 1 over 18. Move here. So y equal to 1 over 18 x minus 1. Okay, so find fx. Find fx, you just integrate that. So integral, so fx equal to integral of 8 2x minus 3 or 1 over 2 plus, sorry, minus 10 x 2 over 3. So to integrate this, it will be 8 2x minus 3. So 1 over 2 plus 1 is 3 over 2 divided with 3 over 2 2 minus 10x. So 2 over 3 plus 1 will be 5 over 3 over 5 over 3 plus c. Okay, for this is actually a x plus b power of n. So when you integrate this, you will get ax plus b n plus 1 over n plus 1 a plus c. So just into this. So it's going to be 3 sorry, it should be 1 over 3, am I right? Yeah, I'm sorry. So it should be 1 over 3. So 1 over 3 plus 1 is 4 over 3. So this will be 4 over 3. Okay. So it will be 3, 2x minus 3 power of 4 over 3 minus 6x 5 over 3 plus c. So we can use the coordinate from here 1, 0. So when x equal to 1, y equal to 0. So 0 equal to 3, 2 minus 3 power of 4 over 3 minus 6, 1 power of 5 over 3 plus c. Therefore, your c will be 3. So your equation, your fx is equivalent to 3, 2x minus 3 power of 4 over 3 minus 6x power of 5 over 3 plus 3. Okay. The last part here, it is given that f prime is equal to 0 can be expressed in this form. Determine, making your reasoning clear, if f is an increasing function, a decreasing function, or neither. Okay, so first we try to attempt to find the turning point, whether you have a turning point or not. And if there's a turning point, then we find where is the turning point, or what's the coordinate. Okay, so we do b square minus 4ac first. So negative 1 to 8 square minus 4ac. So I got negative 79616. Okay. So since b square minus 4ac is less than 0, there is no turning point. So it's either always increasing function or it's always decreasing function because there is no turning point. So we try to find, so here the domain given is x more than 0. So we just sub in. So f prime x will be 8 2x minus 3 power of 1 over 3 minus 10x power of 2 over 3. Okay. For any positive value of x, 2x minus 3 power of 1 over 3 is always negative. Okay. So your f prime x will be always negative. Okay. Always negative. Okay, because if this is negative, okay, so negative number multiplied with 8 will be negative. So negative minus negative is always negative. Okay, when you're for any positive value of x. Okay, therefore it, since your fx, your f prime x, sorry, is always negative, therefore your fx is decreasing function. It's a decreasing function. Okay, so that's all from me. Thank you.